So we have to begin with Narnia 3. Narnia 3's password is this one. We got it from previous level. So let's clear that. We know that all the data exists at cd/Narnia. So this time our focus will be on these two files. Let's see what this file does. Narnia 3. So this is the usage. So Narnia 3 and some file should be given, and this contents of the files will be sent to some other file. Okay, in this case the file seems to be a null file. Okay, /dev/null. So let's try to give a file to it and let's see what happens. Let's try to give the password of this Narnia 4. Okay, /etc/Narnia_pass Narnia 4. Okay, so let's see what happens. So it's saying the contents of Narnia 4 to a safer place. Okay, so that safer place is /dev/null. So this is not what we want. So we cannot retrieve anything that goes into /dev/null. So let's see the contents of Narnia 3.c file. We have some headers here and int main. So this is the main function and it's accepting some arguments. Some variables are initialized. So IFT, OFT, I'm not sure what this is, but this seems to be the output file. It's sending to /dev/null and looks like that is what happened, right? So we gave this as an input file and this was the output file. So this input file is taken as Narnia 4 file and this output file is sent to /dev/null. So this is not we wanted. Okay, so since this is initialized first and then this is initialized, if we try to give anything into this variable, if we exceed 32 bytes, it will try to overwrite this file next. Okay, so if you remember, all the initialization happens from higher memory to lower memory. So if something exceeds in the lower memory, it will override the contents of the variables or functions which are in higher memory. Okay, so we have seen that in Narnia 0. Okay, so I'm just recapping this. So in that Narnia 0, this was initialized first and then this was initialized. Okay, so it will keep track from higher memory to lower memory. So if anything goes in variable that exists in lower memory, if it exceeds the limit set by the program, it will try to overwrite previously initialized value. Okay, so this is the same case. This has 20 bytes and once it exceeds, it is trying to overwrite the previous initialized variable. Okay, so same thing happens here. If it doesn't contain any argument, print this. Okay, so it is 2 because as you can see, this is program and this is an argument, right? So it is taken as first argument and this is taken as second argument. Okay, this is how in general C program actually sees. Okay, if it doesn't detect any arguments, so it simply says that usage Narnia 3 file and something something. Okay, so same thing happens here and then it exits right there. Okay, so if we give some argument, then this condition will be skipped and then this function will execute. So in this function it says that whatever is the argument given, that argument will be stored in input file. Okay, so Narnia 4 was stored in this I file. Okay, so that is what it's saying. So once this is done, so this condition says there is an output file and this output file should have read write permissions. Okay, if this doesn't exist and it cannot open the file, then it's going to say error opening the file. Okay, and then it exits over here. And similarly, an input file is checked, this file. Okay, so this file is checked and this file should have read only permissions. Okay, and once it is able to open this file, this is stored in this input file. Okay, and if it cannot open this file as read only, then it's going to simply say error opening the file. Okay, so copy from file 1 to file 2. So this is going to read this input file, this is going to write this output file, and whatever the contents of this input file are being transferred to output file. Okay, and then once this is done, this will close the files. Okay, so what you have to do is you have to create an input file or use the existing Narnia 4 file in some other way. Okay, so we'll see how we can do that. And this file should have more than 32 characters, and once this 32 characters are filled, this output file will be overwritten, and this output file should also be accessible. Okay, so this file should be so big so that it can overwrite this and also create a new file over here. Okay, and this file should also be accessible, or else we don't know where we can find the contents of the output file. Okay, so the contents of the output file should also be accessible to us. Okay, so we have to create in such a scenario. So let's see how we can do that. So there is a place where we can actually create lots of files, right? So that directory is called temp directory. So everybody knows this. So we just moved to temp directory. So we have to create an input file. So let's say that input file exists in some other directory. Okay, /tmp/ some directory which is more than 32 characters. Okay, so let's type 32 characters including this /tmp and /. Okay, so already 5 characters are done, so you have to say 27 more characters, so that 27 plus 5 will be 32. Okay, so let's say 1 2 3 4 28. Okay, so let's say 27 characters. Okay, plus 28, 29, 30, 31, 32. Okay, so till here we can say input file is buffer is filled. Okay, this part is filled. So once this is filled, whatever we type will be going into output file, right? So output file should also be accessible to us, and it should contain less than 16 characters. Okay, so since we can access temp directory, so let's create a sub temp directory over here. Okay, so since this directory doesn't exist, we have to say that mkdir/p. Okay, so this /p will create some kind of parent directory to this, so that this directory can be created. So this directory is created. Okay, so we have to create a new file into this directory, so that when we try to access that file, Narnia 4 file will be accessed. Okay, so we have to create a soft link for that. So let's create a soft link, Ctrl+Shift+V, and then some name of the file. So this file, let's say HMCyber, this file doesn't exist in this directory, so we are creating a soft link. Okay, so to create a soft link, first you need to mention the actual file. So Narnia_pass Narnia 4, and then the soft link that you're creating. Okay, so this HMCyber file will be created in this directory. Okay, so let's say -l. So this is a soft link right now. Okay, so this link is actually directed to this file. So let's also see the permissions of this directory. Okay, so it says Narnia 3 can read, Narnia 3 can write, others can read. Okay, so which means others can access this file, which means if Narnia 4 is there, Narnia 4 can access this file. It can read whatever the contents. Okay, so hopefully this will execute. If this doesn't execute, we have to give 777 permissions to this directory as well. Okay, so let's try without changing the permissions. Okay, so once this is done, we need to also create some file in temp directory, so that would be the output file that this file can detect. So let's create that file, /tmp/hmcyber. Okay, so we have created this file. Let's give this permissions to it, chmod 777/tmp/hmcyber. Okay, so we have given full permissions to it, so that this file can write into this file. Okay, let's try to run the file. Okay, so the file is in /Narnia/Narnia3. So this is the file. So we'll give an argument in this format. Okay, and HMCyber. So we're trying to access this file. Okay, so when we're trying to access this file will be triggered, and then the contents of this file will be transferred into output file, right? So since this is the input file, this already has 32 characters, and whatever is excess will be given as an output file. Okay, /temp/cyber /cyber will be the output file right now. Okay, and this whole thing will be the input file. So let's see what happens. Okay, so copied contents from this file, which is actually this file, to a safer place, which is /temp/cyber. Okay, so let's copy this, let's cat this, and here we got the solution. Okay, so I hope you get it, and I'll see you guys in the next one.